Alright, good day everyone. Today we're going to be doing number systems. Alright, for Maths 130, this is very important to know your numbers and where they come from. Now, obviously, 1, 2, 3, 4, 5, 6 doesn't end there, okay? Somehow Maths went to the extreme to getting numbers which you didn't even know, to be honest with you. So, number systems. First, there's two numbers which you can differentiate, right? Real numbers versus non-real, right? So, real versus non-real. Now, non-real, right? So, now what is real numbers and non-real? Non-real. Okay, so real numbers are anything. It can be 5, it can be 10, okay? It can be 5.5, 10. It can be literally any number. It can be a fraction, 1 over 2, 1 over 10, 1 over 5, okay? Square root of a million, square root of 1,000, square root of 10.5. Those are real. Now, a non-real number is basically a square root of a negative, right? The square root of negative 2. Now, I'm saying a square root, so it's not a cube root, it's a square root, right? So, any square root, you'll put in your calculator, you get an error. Because these numbers don't exist, right? They call them imaginary numbers because, you have to imagine them existing because they do not exist. You can't get a number out of this, right? So, this is real and non-real numbers. Now, from the real number system, there's lots of other things. So, like maybe rational. So, rational is represented as a Q. Irrational, it's like that. And then you got integers, which is like this, like a Z. Integers. Then you got natural numbers. Okay. Let's see if I'm missing anything. Natural, integers, irrational, rational. No, I'm not missing anything. It's perfect. So now, what is natural numbers? It's all numbers from 1, right, to infinity, right? Positive infinity. What I mean is 1, 2, 3, 4, 5, 6, 7 to infinity, right? It won't go 0, -1, it won't go that, right? So from 1 to positive infinity, okay? Now, integers, on the other hand, are basically numbers. It can be negative, it can be positive, but they're whole numbers, right? They're not fractions, they're whole numbers. So, for example, -1, 0, 1, 2, okay, to positive infinity, and this to negative actually, I can't say that because it doesn't include the decimal there. So, yeah, and then obviously it goes on, okay? It goes on and goes on. So, these are integers, right? So, -5, -4, -100, -1,000, -1,000,000, maybe 1,500, 1,800. What's not an integer is 2.5, 3.1, square root of 7, 1.9. Any decimals are not integers. To basic simplify, decimals are not integers, fractions are not integers, whole numbers, right? Perfect. Next one, let's do rational first. Now, rational is any number that can be written as a fraction. If I tell you, is 10 rational? It's rational. I can rewrite 10 as 10 over 1, okay? And this is rational. What is 7 rational? Let's see, 7. Yeah, 7 over 1. It is 23.5 rational. Yes, 23.5 can be written as a fraction. 23, what is 23 double? 46. So 45 over 2 is 23.5, isn't it? I'm not sure. 23, no, I don't think so. Okay, whatever, but you get to understand. 23.5 can, oh wait, 23. Okay, you know what, never mind. I'm not good at calculating mental math, which is bad because now we're not using a calculator. But you get what I'm saying. I'm sure 23.5 can be written as a fraction, right? So anything can be written as a fraction is rational. Now, irrational is a number that cannot be written as a fraction. For example, pi, right? 3,1415, and it continues. It can't be written as a fraction, right? You call numbers that go on forever recurring decimals, right? So 3.12111, it goes on, versus terminating, which is like 31.25. Okay, it stops. Now, irrational, the best way to see if a number is rational or irrational is to obviously put in a calculator, and if it simplifies to a fraction, then obviously it's not irrational. But obviously we can't use a calculator. But it's very, very obvious, right? Because we're not using calculator, they're going to make it obvious. So we're going to probably have like 1 over 3. And they'll say, okay, is this rational or irrational? That's rational. You can rewrite 1 over 3 as 1 over 3 has 1 over 3, you know, and 1 over 3 is 0.333333. It's recurring, it doesn't end, but that's rational. So anything that can be written as a fraction is rational, okay? Anything that can't be written as a fraction is irrational, okay? Also, they say to know if it's rational, it's basically an integer over another integer will give you a rational anytime, right? But obviously the denominator can't be 0, right? That make it undefined. So if an integer is 5, which is an integer, over 2, that's irrational, rational. But if you get a not integer, so like 5.79 divided by 3.99, which is not an integer, then it becomes irrational. So yeah, that's it. So this summarizes number systems. Now I'm going to show you, so a number system is very, very easy to predict what's coming out in the paper for maths or class test, because number systems is like 2 or 3 examinal concepts from that. So technically, if you just learn those examinal concepts, it's done. So what I'm going to do is the next video is I'm going to do those examinable concepts. In fact, I'll do a past paper, okay? So you know that I'm not, it's actually real, right? So, and yeah, number systems, you can score your marks over here, okay? It's not that hard, but it's hard. But if you work with it, it'll become very, very easy.